Good morning, good afternoon, good evening. Welcome back to chapter 34. We're still talking about ecosystems. We had just finished up talking about the terrestrial ecosystems. Let's talk about a few aquatic ecosystems. Talking about aquatic ecosystems, the first one I want to talk about is a freshwater ecosystem. Freshwater would be like lakes, streams, rivers. There are a few different zones within a freshwater ecosystem that I want to illustrate for you. So if we have, imagine a lake, and in our lake, here's our water level. Understand that light can only penetrate so far down into the water. And if we say that this zone, that the distance that the light can penetrate is only so far down into the water. Below this dotted line, light can't penetrate with enough intensity to support photosynthesis. That's referred to as the aphotic zone. Below that line, the light cannot support photosynthesis. We have these two little areas right here along the bank. This little area here and here is the bank is close enough to the water's surface that photosynthesis can be supported. If a plant were to root right here, it could grow and reach the level of light penetration that is sufficient to support photosynthesis. So these two little areas right here, along the bank, right along the edge, is referred to as the littoral zone. The littoral zone. Imagine if a seed fell in the water and made it all the way down here. When that little seed sprouts and my little plant comes up and tries to grow, what's going to happen? It is below the distance that light can penetrate to support photosynthesis. So what's going to happen to that poor little plant? It's going to die because it can't reach light. So what about this whole center area then, where it's shallow enough that light can penetrate to support photosynthesis, but it's too deep for plants to grow? What are we going to find there? Well, we'll find algae there, and that region, the top of the middle, is called the limnetic. Below here is the aphotic, no photosynthesis. The top area is the limnetic. These two little areas right around the edge is called the littoral zone. This area up can support photosynthesis, this area down can't. Just want to get that close enough to make sure that you can see all of my different little drawings. Freshwater habitat. River, mountain, lake, freshwater habitat. Saltwater habitats, the zones are similar, but they're a heck of a lot larger. There's just a lot more middle. We still have the top of the middle that can support photosynthesis, but is too deep for plants to grow. We still have the edge. The edge is shallow enough that plants can grow. And then you've got the bottom, the aphotic. Way more middle. In saltwater, we actually have a number of ecosystems. We've got these hydrothermal vents we'll talk about in just a second. There are coral reefs. There's all kinds of ecosystems within the ocean itself. This is showing the ocean. This neritic zone is this area right here. Again, Notice that photic zone, the area where light can penetrate sufficient to support photosynthesis. In this area right here, this neritic, this is the saltwater's version of the littoral zone. This is where it's shallow enough that can support photosynthesis and plants. The photic zone is the top of the middle. That's the area where photosynthesis can happen, but it's too deep for plants to grow. So you can find algae and things like that in there. And then you've got, in this case, the benthic. And the benthic is the bottom. And you have lots of stuff that falls to the bottom. Like we talked about when we talked about filter feeders, eating stuff that's falling in the water column. And this whole area below this is all called the aphotic. And the aphotic is simply where light cannot penetrate. I didn't get a chance to talk about the hydrothermal vents. Let me back up and do that. The hydrothermal vent is a rip in the surface of the planet. This rip in the surface of the planet, they're found in the bottom of the ocean. These hydrothermal vents are sometimes called smoker chimneys because it looks like smoke is spewing out of these rips in the ocean floor. It's not smoke that's being spewed out, it's sulfur compounds. Within those sulfur compounds, within this sulfury water, superheated sulfury water that's being spewed out, we'll find Archaea. We talked about Archaea already. This is the only ecosystem, it was the only ecosystem that we'd known, where the sun is not the original source of energy. The original source of energy are those sulfur compounds. The Archaea use chemosynthesis. Photosynthesis uses light to make food. Chemosynthesis uses chemicals to make food. Specifically, the chemicals that Archaea use to make food is these sulfur compounds. They take the energy from these sulfur compounds and use that energy to make food, and then they use that food to feed themselves. Only ecosystem on the planet that does not have the sun as the original source of energy. If we think about that, that's really, really odd. Every other ecosystem on the planet uses the sun for its original source of energy. The hydrothermal vents don't. It is thought that they were perhaps the first ecosystems. And each of these hydrothermal vents are so far spread from each other that each one essentially will have its own miniature ecosystem that exists around it. Really, really interesting areas. Next are wetlands. Wetlands are where water and land meet. Swamps, marshes, bogs, salt marshes, areas like that. When you see an area like this, you think, ew, gross. Think, I wouldn't want to go there. That's terrible. It's mud, there's going to be bugs, there's going to be alligators and crocodiles and snakes and water moccasins and all kinds of stuff down in there. It's going to be all kinds of gross and nasty stuff. I don't want to go there. Yuck. What's going to be in there? All kinds of stuff. In these marshes, you've got everything that life needs. You have warm temperatures, you've got direct sunlight, you've got water. That's why there's so much life in these things. There's so much life in wetlands because it has everything that life needs. It has, and that's why there are so many bugs. Why are there so many bugs? Because there's so much water. Why are there so many reptiles and amphibians? Because there's so many bugs to eat. Why are there so many every other thing in there? Because there's so much stuff to eat. Because there's so much life in here. Wetlands.